Okay, so today, it's the beginning of a unit we call quadratics. And I know you know what a quadratic is. And I did this unit different this year because I did the lab first. All right, the lab was about quadratics, and so you did the lab about quadratics to remember what you had done in the past with quadratics. I'm just going to go off and sidestep and remind you, here's what you did in the past with quadratics. You had a ball that would go up in the air, and then I've already reminded you about all these things in a course teaching you that lab. And so, what's that spot called? Y-intercept. What's that spot called? Vertex. What's that spot called? The x-intercept. And the x-intercept is found with what formula? Quadratic. X equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, and I should squeeze in a c there. Okay, and then this formula, do you remember this one that only about 4 kids knew? Yeah, x equals negative b over 2a. That also is the equation of this line that runs down the middle. You remember what that's called? Line of symmetry is close. Axis of symmetry. The axis. I like to call it the axis of symmetry because it's an x equals line, right? All right. So that was a great way to get ready for this chapter, was to do the lab ahead of time. And now you've bounced a ball or threw a ball up in the air and had that whole experience. That lab will be graded here sometime soon. And I think you figured out that the key to the whole thing was figuring out this part right here. What was that B term? The velocity. And you had to figure out the velocity by using 2 things, really. All you really had was the time it was in the air, but you also knew when it hit the ground. And so the time and hit the ground is actually 2 things. Time and height when it hit the ground. So that's actually 2 things. You can stick it in the equation, and anyway, I'm being vague about how to do that because it's the whole point of the lab. All right, we are going to go over the test. In my opinion, that's best done at the end of the hour when kids can work on their homework if they don't have any questions, because you mostly got A's. So a quick reminder, standard form is this one. AX plus BY equals C. Slope-intercept form is this one. And I talked to a calculus teacher about this once, and she said, you know what, kind of de-emphasize slope-intercept because they already know that one. And the one we use the most is this one, point-slope. All right, so where does this point-slope one come from? I'm going to show you where it comes from. And I know some of you guys know this as the slope. Y minus the y over x minus the x. And I used y and y1. Some of you guys know it as y2 minus y1. It doesn't matter. It's just got 2 points. And you're subtracting their y's over subtracting their x's, right? Well, guess what happens if I multiply both sides by x minus x1? Do you get, I just get y minus y1 equals m times x minus x1. It's just a rearrangement of the slope formula. So it's not like it's a new formula. It's just the slope formula, except rearranged. Okay, that's why if you want to, you can actually put in all the numbers for the 2 points and it'll tell you the slope. It's not solved nicely for the slope, but you could do it. You could do that if you wanted to. So I know that you know how to find the slope. Common mistakes though, if I go 4 minus 0, then I can't go 0 minus 2. Just look what I just did there. That is a mistake way to do it. 4 minus 0 was fine. But then I'd have to go 2 minus 0 on the bottom. Do you see what I did there? If I'm going to take this one minus this one, then I have to do the 2 minus the 0. You got to stay consistent. You can't switch around the number on the top or the bottom. I don't know if you've ever noticed this before, but if you switch something around and it's a minus, then you just changed its sign. Okay? If it was 5 minus 3 and you switch it to 3 minus 5, you just switched its sign. If you reverse to a subtract problem, you just changed its sign. So yeah, you'd screw up your problem if you did it that way. This would have to be 2 minus 0. So then it's really 4 over 2, which is really 2. And yeah, you found the slope. And then you just plug it into y minus y1 equals m times x minus x1. And again, I know you know this, but I need to do 1 for the video at least. So let's do this point right here. And of these two, which one's going to create the more clean simple answer? 0, 0 or 2, 4? 0, 0, but the problem with 0, 0 is that it's going to make it look like your answers are all going to say y equals 2x, and it's not always that simple. So 0, 0 is beautifully simple. But a better example would be to use the 2, 4. But everybody please put in the 2 and the 4 in the right places, and then tell me what equation you have. So write the equation out with the 2 and the 4 in the proper spots. The slope is 2. So then I'd have y minus, and the y of it is 4. I get why people want to put the 2 there, because you see the 2 first, and then this is the first number you have to plug in, but you got to reverse them from normal because the y goes here. This is where the y goes. And the slope was 2. And then I have x minus the x of 1, which is, what is the x of that point? 2. And there we go. Now, can you leave it that way? That is a good question. Yes, you can leave it that way. But a lot of times, in the real world, they're in different forms. So let's talk about the different forms that this equation could take. If I leave it like this is an equation. But do you agree that there's some simplicity to having it solved for y? Because then it goes into a calculator easier, for example. There's other reasons why we might want to solve it for y. So I'm not against that. What you usually don't ever see is this. You do sometimes. You sometimes see that. But that's usually if it's going to be squared and it's a parabola. Okay. So if it's not squared, then it is probably best to just write it all the way out. 2x minus 4 plus 4. Wait a minute. Y equals 2x. That's what we got before. So remember how we said if you put in 0, 0, or if you put in the other point, either way you get the same answer. They just look different. But it's the same answer. Y equals 2x or this. Either one are correct. Okay, possibilities. Okay, moving on. This is the same thing except it uses words. The ACT has word problems in it. They don't just give you like, what is this equation? Or no, here is an equation, solve it. That's really rare. They usually give you words. I'd like you to note that this is just the same exact thing. They've given you 2 points. They're going to ask you for a slope. It's just that they want you to interpret what slope is. I think this would be worth a minute. So everybody take a second, solve this one, and figure out what the answer means. Okay, so when it said find the slope of the line, hopefully you just did the slope kind of the normal way, and you took 32 minus the 24, and you put it over 10 minus the 6. What did you get for an answer? 2. Now, what is that? I know it's a slope, but what is it? What's it about? Like how fast you're killing mice? Yes?
How many degrees of increases per hour?
All right. So y equals 2 means it's really actually a rate. What per what?
2 degrees per hour.
Degrees per hour. Okay, cool. Now, predict the temperature at noon. Well, at 6 a.m., it was 24. And at 10 a.m., it was 32. So, well, I guess I can predict the temperature at noon is it's going up 2 degrees an hour. I just go 2 more degrees. No, 4 more degrees. So that's going to be 36. Do I have that right? Okay, good. All right. Now, I want to take a second to talk about the equation for the lab. And this is an important, the units are a big deal. And in math, a lot of times we just ignore the units until the end, and then we say, don't forget it's units squared. Okay? Well, where did they go in the meantime? Science is a lot better about always including the units in there, like in everything, right? Well, let's talk about this negative 4.9 t squared plus, let's say you threw it at 8 was your velocity. And this last thing is like 1.6 meters. Let's say that your starting height was at 1.6 meters. All right. So what are each of these things? What are the units on each of these things? Well, let's start with what they are, okay? What is time? That's in seconds. Well, obviously that's in seconds right there, right? All right. How about this over here on the end? What's that y equals? What's that? It's a height. That's in meters. Okay? And the time, if I just take 8 times some number of seconds, it would have just been seconds. But wasn't the 8 actually a unit? What was the 8? So that was 8 meters per second times the time. This is the rate times the time, which was in seconds. Do you get how if the time's in seconds, it's going to cancel out and it's meters? What's this one on the end? That's meters. What's this one on this end? That's meters. Do you get what I'm doing here? They're really all turning into meters. Okay, how about the big daddy of them all? That one. When I do the time, here's the negative 4.9. That was technically the gravitational constant, and then divided by 2 gives me the negative 4.9. And do you guys know what that's in? Meters per second squared. Very good. And then you times by the time. This was the rate that it's falling towards the earth, and this is the time, and that's in seconds, but it's squared, you know, because it's time squared. So this is in seconds squared. Do you see how those cancel and I end up with meters again? See what I'm saying? What's the moral of the story? All of those were really in meters by the time they were done canceling their units. So if we go back to this original equation, here's the reason that is. Because you can't add a rate to a distance and have it make any sense. If I go 180 miles per hour for 4 hours, can you add the 180 miles per hour and the 4 hours? Can you add them together? No. If you have a bunch of things that are being added together, they all have to be the same thing. They all have to be the same units. Does that make sense? Okay. Can you add rates together? Yes. I can add miles per hour to other miles per hour. So if I, picture this, I'm on a plane, and the plane is flying at 600 miles an hour, and then I start running on the plane. I start running in the same direction the plane is going. You get what I'm saying? First of all, they'd probably tackle you because you think you're running to go to the cockpit of the plane and like, you know. But if I start running from the back of the plane to the front of the plane really fast, yeah, I'm going to alert the air marshal and I'm probably dead. But if I'm going at 10 miles an hour, okay, and then you add that to the 500 miles I was already going in the plane, now I'm going 510 miles an hour. You can add rates together. But you can't add a rate and a time. But you could multiply a rate and a time, but you can't add them. Okay, so the reason I'm bringing this all up is we're going to get into this weird part where we're going to have rates that are going to get added together. And the rate will equal a rate plus a rate. And that's okay. You can add things as long as they're the same units. And then I never really have talked to a class before about how in an equation like this, this is actually all meters. They're all meters the whole way. Meters equals meters equals meters. It can't be any other way. You can't say like 6 meters equals 4 seconds. That doesn't make any sense. Okay? All right. So, how did this become meters again, Mr. Server? Well, it was because it was 8 meters per second times seconds for the time. And then those canceled, and that's back to meters again. Okay. I think I've beaten that to death, but I know why. And I hope you'll see it when it come to it. There's going to be a time when all of a sudden our rates have to like all add up. And I think it'll help make that make sense. Okay, This is the same stuff we talked about before, the same exact equations. So I'm going to move on to the next one. How is this any different? They just call it a constant function. So if we're talking about different kinds of equations, would you agree that's the simplest kind, y equals 3? And if you made a graph of that, it would just be like a line that goes straight across the 3. What if I said y equals 3x? Did I up the game a little bit? Yeah. Now it's got a slope. Now the line can't be just flat. Now the line will have like a slope to it. How about if I go y equals 3x squared? It changes again. It's a little more advanced. Now it can have a curve. What if I go to the third power? Now it's got a set of curves. And it'll have more and more and more curves. All right, and that's what you learned in higher algebra, is you went from having a straight flat line to a tilted line to a line that would curve to a line that has lots of curves, like high spots and low spots. Okay. All right, I'm just trying to give you some context here. So here is a constant function. That's the one y equals mx plus b. What's that? What's that third one there? Anybody know the type of function that's called? Hint. It can be written as a fraction. I hope that snaps a word into your mind. Can be written as a fraction. Nobody? You all fail the ACT. I know, you probably won't, but it'd be better if you knew this. Certain kind of numbers can be written as a fraction. Yes. Rationals. Yes, this is called the rational function. It's a rational function. All right? This is also a rational function because it's a fraction function. It's a function that has a fraction in it. And this is even a better example of it because it's got an x on the bottom. All right? So, if I want to get the slope, it was easy to get the slope here, although you don't really think of it often as a slope. But what is a line that's just going straight across? What does that have for a slope? 0. How about the slope of that? I just circled it, and yeah, that's the slope of 3. I know you know that, but you probably weren't looking at the board at the time. And then this one, how about this guy's slope? Can you see it buried in there? It's the thing stuck to the x, but it's not just the 2, and it's not just a negative 2. Doesn't that 4 on the bottom matter? Sure it does. So it's negative 2/4. So if you wanted to simplify that, would be what? Negative 1/2. The slope of that guy is negative 1/2. I can see it. It's right there. It's the number in front of the x, and then you got to make sure to divide it by 4. All right, so what's the slope of this last one? U. Do you remember me telling you we were doing this thing that you're actually going to do in calculus someday, and it can tell you the slope of curved lines? Does that ring a bell at all? No, it wasn't a differential equation. No, it was a difference quotient. Very good. Okay. But why is this one different than the difference quotient? Because we don't need the difference quotient for this one because, let me show you, if you can factor it, you should. So everybody factor number 4. And I think certain things will come to light. X plus 2, x minus 2. Do you get that the x minus 2's will cancel? So you really just have a straight line again. It's really just y equals x plus 2. Is it really just that? Yes, kind of. It's got one little difference. This function is like allergic to peanuts. Except it's what is it allergic to? 2's. Because if you ever fed it a 2, do you get how it'll be dividing by 0? So it's like this straight line, except, caveat, little star here, x cannot equal 2. Because if it does, then the function would have died. Because the function was actually this function. And then you see when you put in the 2, it dies? All right, so that's pretty much a straight line. What was the slope of that straight line? 1. So it had a slope of 1. It was a straight line with a slope of 1, but it has a weakness for peanuts. Or in this case, 2. Doesn't look like it. Well, you can't see it on the outside. Somebody's allergic to peanuts. You can't just look at them and go, oh, they're allergic to peanuts. You can't see that. Okay. Is it really that simple? Yup, you're at the part where I can give you the homework. It was a really easy day today. And that's one of the reasons I took today. I think the other ones are just going to be too simple. Seriously, graph that? Come on. So I guess, okay, this one, some of you guys have forgotten how to do these. It wouldn't hurt you to do this one. Worst case scenario, what if you're like, yeah, I've totally forgotten how to do that. I have no clue what that looks like. What's your best friend in graphic? XY chart. So we're going to start on problem 26. We're going to skip everything up before that. And just do 26 and the moment to talk about the lab. I want you to do the word problems where those rate. But all the other ones. Okay. And there we go. That's all I have for you for today. If we have time in class, I could see us grading the lab today. But if we don't, then we'll do it tomorrow or the next day. I also need to get the test back to you. So, and that's it for the video for today. The rate equals a rate equals a rate. All right. So how does this even get hard at all? The word problems. This one says challenge, which means I don't need you to do it.